This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make lightning protection easy. If your wind turbines are due for maintenance or repairs, install our Strike Tape retrofit LPS upgrade at the same time. A Strike Tape installation is the quick, easy solution that provides a dramatic, long-lasting boost to the factory lightning protection system. Forward-thinking wind site owners install Strike Tape today to increase uptime tomorrow. Learn more in the show notes of today's podcast. Welcome back. I'm Dan Blewett.
I'm Alan Hall.
And I'm Rosemary Barnes.
And this is the Uptime Podcast, bringing you the latest in wind energy tech, news, and policy. All right, welcome back to the Uptime Wind Energy Podcast. I am your co-host, Dan Blewett. On today's episode, we've got a very full schedule here. We're going to talk a bunch about policy. We've got an interesting tax credit being proposed in the United States Congress that will help keep investment in U.S. manufacturing. So we'll see how that plays out. I know Alan has strong opinions there. We're going to talk about stocks and business for a while. Orsted had a great year, or at least in this first half of 2021, up 186% their revenue. We'll talk about Iberdrola potentially spinning off their offshore business, GE stock, and some of the implications of their 10-to-1 reverse split. And we'll chat a little bit about Vestas and others lowering their financial guidance due to COVID, inflation, materials, stuff like that. An interesting little story. It's right up Rosemary's alley. A Virginia girl won a national wind energy contest here in the U.S., submitting designs. So she's got some love for that design, and we'll talk through some of the challenges of growing more engineers all over the world because we need more of them. We'll also talk a little bit about windbreaks. Some research has come out about them, potentially increasing turbine output. And lastly, we're going to go back to thermoplastics. We had a little bit of unfinished business previously. We want to talk about some of the lighting implications of some of the foils that are internally sandwiched in the blade on the welding process. So before we get going, let me remind you, A, thanks for being here. B, you can sign up for Uptime Tech News, which is our weekly newsletter where we'll shoot you a quick email of the new podcast, some other helpful links, stuff that we find valuable all over the web. So if you want to stay up and be a wind insider, definitely sign up in the show notes, whether you're listening on iTunes, Spotify, or Stitcher of today's podcast. Let's talk about this tax credit. So it sounds like Senator Markey, who's from your neck of the woods, Alan, and others are introducing a tax credit that's going to create a 30% investment for qualified facilities that manufacture wind components for offshore here in the U.S. And it looks like that will eventually be phased out between December 2028 and completely around 2030. So, Alan, do you think this is going to work? Are we going to be able to put up some of these facilities in the U.S.?
Well, big corporations will take that tax break immediately and hopefully put it to work. The question is who and where and how. It's easy to make proposals like this, and this is the trouble, I think, with sort of the Massachusetts delegation, because this comes up quite a bit, where they want to make some world-altering proposals, and then you check up on it 6 months later, and nothing has happened. And it is super frustrating to watch this go into something I'm more familiar with, which is just offshore wind and wind turbines. Massachusetts itself doesn't have a lot of wind turbine manufacturing, so to speak. The university system does some research, and it is one of the national leaders in some wind turbine technology stuff. But in terms of manufacturing, there's very little. And it's unlikely that a lot of that will happen locally in Massachusetts, and there's a variety of reasons for it. Resources, access to roads, all of those things play into it. So in terms of wind turbine manufacturers or component manufacturers for wind turbines, my little company is probably one of the larger ones at the moment. And, what are we going to do with the 30% manufacturing break? That'll never come to a company like ours. So it is, in one sense, I think they're trying to promote the industry, and I get all that. And on the second sense, you have to play with the big boys, and we're just not a big company to start making phone calls to the senators and Congress people about promoting wind energy. So I just don't see this going anywhere. And it'd be lucky right now with everything that's happened in the United States that it would pass, that the president would eventually sign it. There's so much. Congress has a 9% approval rate. So
Yeesh.
Proposals like these.
I wasn't aware of that. Yeah.
Yeah, proposals like this tend to get put out and the press releases get put out, but action really doesn't happen. And then that's one of the reasons why they have a 9% approval rate, because of these kind of proposals. So we'll see.
Rosemary, what's the climate like for you in Australia? Does the government really push for as much local manufacturing as they can, or is there an increase in that, or what has the climate been as far as like local manufacturing?
So recently, Australia hasn't really been too strong on manufacturing, or at least that's been like the prevailing wisdom. We had an automotive industry that was subsidised by the government, and when they pulled their subsidy a while ago, people kind of thought that was the end of manufacturing in Australia. It wasn't really true, because we've still had quite a lot of advanced manufacturing happening, and in a few kind of key sectors. But certainly it's been a really long time since we had any kind of major solar panel or wind turbine components made in Australia. We do have a new government plan, 6 national manufacturing priorities, and one of those 6 priorities is clean energy and recycling. But even then, the government isn't really expecting that we're going to be making a lot of wind turbine components or solar panels, mostly just because, we can't really compete with the low labor cost countries on those types of components. However, I was talking to a guy who's involved in some of those really huge hydrogen projects that are planned for some parts of the Australian desert in Western Australia, and I think also South Australia. And those plans have, huge solar farms and really huge wind farms as part of them. And he mentioned to me that because there's going to be so many wind turbines involved, that they were looking into getting a wind turbine factory locally just for those wind farms. So he was quite optimistic. And I mean, I have to say I'm a little bit skeptical, but I really hope that it's true, because I would love to see wind turbine manufacturing in Australia, especially blades. That's kind of like a dream of mine, that we would get some of that in Australia.
All right, so next on the docket, let's talk about Orsted. So their profit is up 186% in the first half of 2021. Alan, does this surprise you? I mean, they're all over every offshore wind project, right? But this seems like a really big increase, yet in this article from offshorewind.biz that we've all sort of read here, they've talked about how actually they've been hurt by lower wind speeds this year. So it sounds like despite some lower wind speeds, they've still had a really big bump in revenue. And it looks like that was really just about them adding about 10% to their total capacity. Is that how you've kind of interpreted their reporting?
It is. It is notable to say that the average wind speed has been low, which is obviously it's an average, right? So it's going to move up and down, but it's on the lower end, and it's unusual to read a financial report that said we didn't generate as much as cash as we normally would because the wind has been slow. That was hard to take from an investor standpoint. Like, well, you're in the wind business. The wind not blowing hard enough can really wreak havoc. You would think on average it'd be average. So that was curious, but
I love it. I think it's amazing that wind farmers are actually farmers, in the sense that they have to pray for wind. Like, that's hilarious. I mean, maybe here's my big idea of the day is maybe they could build some sort of big wind generators, these big fans to then push wind to their turbines. You'd have, obviously that's nonsense, but yeah, well, I think it's so funny that, you pray for rain, 200 years ago, still present day, right? But here they're praying for wind to meet their financial forecast, which they have zero power over. No one has any control over that, unless Montgomery Burns from The Simpsons is going to come back with some device to control, the wind.
Well, you'd think as the Earth got warmer that we'd have a little more energy in the air, and which would turn into more profits for Orsted. So, if global warming is really driving the temperatures up, you would think there would be more wind, right? So that's
stay tuned. There'll be more tornadoes, land hurricanes. We'll have hurricanes mixing with tornadoes. It's all coming. Don't worry. We'll have it all.
Yeah.
But yeah, I mean, Orsted's had a really good year so far. Now they want to be cautious because they're not sure what the second half of the year is going to look like. But
right.
Like I said, you hear their name everywhere when there's new development, especially in the U.S. right now. So it sounds like they're really kind of steamrolling.
Right. I think you got to wonder if the wind turbine OEMs are going to be the big winners in offshore wind, or is it going to be the operators? It may be the operators, and we'll see where the investment dollars go.
Yeah, well, and of course, like we just said, it is nice to be the wholesaler essentially in this. Like, GE doesn't care whether the wind blows, right? They're selling their turbines. They want it to blow, obviously, but their turbines are sold with or with. They don't come with wind. You hopefully get wind with your purchase, but it does not come free with a side of wind. So you get what you get. So they're definitely going to be insulated from those ups and downs, at least. Obviously, every business has unpredictable ups and downs, but the OEMs won't have that. So along these business lines, Iberdrola has had also a good year, and they're potentially spinning off some of their offshore work. Alan, why would they do this?
Well, it's all about markets and financial positions of companies, and in this particular area, a lot of it's about cash and have available cash to sustain companies. And if you can spin off one of your divisions, which will raise a bunch of cash once it hits the marketplace, you as the original company get to participate in that. So it actually raises more value for the investors. And that's why investors demand that really good subsidiaries get spun off, because there's more potential total net growth as a separate company. And that happens quite a bit in the United States on divisions that have the hot new product and that are underneath a larger conglomerate of some sort, that the investors will demand, especially during slow times, they'll demand that those smaller companies or smaller divisions be broken off and everybody can reap the profitability of them. So it's a way of squeezing out cash from an existing entity.
Well, and speaking of squeezing out cash, GE is now starting to do a much better job. This article by the stock site Seeking Alpha, just talking about how GE's dark ages might now be over, where obviously they were this giant conglomerate, the Jack Welch days back in the, Alan, what was it, the 50s, 60s, 70s? What was GE's real heyday?
80s, 70s, 80s in particular, early 90s, mid 90s even. Yeah. Yeah.
Giving rise to the comedy show 30 Rock.
Right.
But, GE is obviously a huge player in wind, and they've got some great technology. Like we talked about the HAL 8X till we've been blue in the face. And they do. And they're obviously doing well on the aerospace side as well. They do great with engines. So it does seem like they're picking up. Their CEO, Jack Culp, seems to have done good work. They've trimmed a lot of their costs. Alan, do you see that? So recently GE has done their 10-to-1 reverse stock split. So their stock was trading around $9. Of course, last summer in 2020, it was down $6, $7. And now they did this reverse 10-to-1 stock split, which has boosted the price. So if you own 10 shares of GE at $9, you then got one share at $90, essentially. So the stock price today is in the low hundreds. Alan, why do you think that they did this? Obviously, we talked about this a little bit before, but is this just part of that sort of, hey, we're back, this is our golden era again? Is that how you interpret this move, or is there something else there?
Yeah, I think so. From a company standpoint, you always feel like GE should be in the 80 to 100 on price range for stock, and they were there for a long time. So when you see GE be in the single digits, it's really worrisome. So they have done a couple of different pieces. One is they are trying to accumulate cash, right? And cash is what keeps a business operating. If you run out of cash, you have to close the doors. So they've been really paying attention to how much cash they have on hand and making sure they have, they're actually increasing, they're doing some buybacks and things of that sort. But basically they're trying to hoard cash, which makes them sustainable. But the other divisions, like the healthcare division, has done really well. Engines hasn't done super well because airplane business is down right now. And renewables hasn't done extraordinarily well. It's done okay. They're sort of paring losses and trying to get it wholesome again. So I think that what everybody's feeling on the investment side is GE is stabilizing himself instead of being in this triage situation where you're just slicing off parts and try to save the remaining pieces that you can. It's stable. It feels a little more stable that they have cash flow to go through some bad times, and they're honing up all those divisions that can generate cash in the future. And on the renewable side, GE is going to be half of the wind turbines in the United States, more than likely, just because it's their home turf and they can compete very, very well in the United States. So if you're forward-looking on the investment side, you say, well, GE Renewables is going to be a big player, and the rest of GE is in places that historically have made large amount of profit. So that's good for GE, and I think everybody on the outside that was poo-pooing GE 2 years ago, even that's all quieted down. I think that the marketplace is going to be better, and obviously the new CEO is going to help do that. There's a lot of legwork involved, just making sure the investors and the stock exchange type, all the investment groups that are down in New York City and around some of the financial centers of the world. There's a lot of hand-holding that has to happen there to give everybody a comfortable feeling like, yeah, GE's okay. And we're starting to get that. So that tells you the leadership group is doing a good job of stopping the bleeding, creating positive feelings, and obviously doing the 10-to-1 combo and the stock price has turned positive for them because the stock price has risen.
Well, and last in this topic today is Vestas. They've lowered their financial guidance, chiefly due to COVID and to inflation. They had a good first quarter of 2021, but now they're saying, hey, with COVID and inflation that's kind of running rampant everywhere, don't expect as much maybe in the second half. And of course, we heard that from Siemens Gamesa as well. We've heard complaints of, not complaints, but, look, raw materials have gone up, inflation. There's been a lot of issues this year with financial guidance, getting those numbers right and just having accurate forecasts for shareholders. So what's your take here with Vestas lowering their expectations?
It feels like the COVID experience hasn't really ended. In fact, we're going through sort of round 2, or in some cases, maybe round 3. And it's hard for a business, particularly a large industrial organization like Vestas or any of them, GE, to try to manage the access to employees. I think that's a big drawdown, and also the raw materials used to make wind turbines, and that's going to be restricted also. And as we see, there's inflationary prices on raw materials, fiberglass, the epoxies, the metals, the steel, all those pieces are increasing in price, and there's really no way to limit it at the moment. You can't buy massive quantities to bring the price down as much as you want right now. No one's listening. So the question really remains as 6 months ago, we felt like most large industrials felt like we were going to be slowly coming out of COVID, and we didn't necessarily consider a variant. And now we're on variant 2, I think. Isn't Lambda the new variant that's going around?
There's a new one, all the time. There was Delta, right. Delta Plus, which people said sound like a streaming service, which very true.
It does.
And then there was Lambda. So yeah, that's these things do. They mutate. It's natural selection in a sense. So yeah,
it is.
Not natural. I want to clarify that comment though. Not natural selection with people, but with the virus. The virus is selecting which versions are surviving and thriving longer.
That's right. It's what's happening, right? It's being genetically modified, and then the ones that are contagious continue on. Mm-hmm. I guess the real question is, what is are these larger companies and countries for that matter going to start doing about it? Because the at least in the United States, and I'll speak for the United States experience, 6 months ago the push was we're going to vaccinate everybody. We're going to try to, a year ago it was, we're going to try to minimize the number of hospital visits and that kind of thing. And what's happening now is we're getting into in which no one's really saying yet, but I think it's going to be the case, is that COVID is never going to go away. The question is, can we minimize the people that are dying from it or having severe reactions to it? And from an industrial corporation, I think you want to get to that point. You want to say, all right, COVID may come around, but at least my employees are going to be safe, or the ones that are at highest risk we maybe need to separate from. But we got to get going, because we can't be in another year of not generating revenue like we have been in the previous 5-10 years. That's just not going to work.
Yeah, and I think that does sound like that probably is the outcome, because you wonder, how could we ever get rid of it down to zero on the entire planet? And knowing how contagious it is, it does seem like it might just be like the flu, where the flu, we live with it, right? We know people are going to get the flu every fall. I'm not saying that COVID is the flu. I'm certainly not saying that. I'm just saying we've learned that the flu is a thing that just always exists, and it never fully goes away. We expect it every year, and some amount of people are affected. We get flu shots, or some don't. Sometimes you get flu shots and they don't work. As I had one year, man, the flu was awful. Yeah, but yeah, that might be a reality. So we'll see. So I want to move on here. And Rosemary, I'm going to throw this one to you first. So a cool article here about a local to me, actually, a Virginia girl in a rising fifth grader named Pranamia Jindal won the 2021 Kid Wind Challenge, which was to design a wind turbine, essentially. So Rosemary, what is your take on her winning design? And the other thing I want to hear your input on is, do we need more contests like this one to help encourage kids to get into science, get into engineering? Because we've talked about how there's a dearth of engineers around the country, around the world rather, and how, especially with all this additional wind power, green hydrogen, all this stuff, we're going to need more engineers. So I assume you're pretty on board with this Kid Wind challenge, and probably want to see more of them.
Yeah, so I had a look at her wind turbine, and I thought it was really cool. It's got some design features in there that are pretty interesting. It's got, did you notice that it had like a modular tower and foundation construction out of some PVC pipes? I thought that was pretty nifty way to handle that part of the design. And it had variable pitch blades. And the thing that I thought was the most cool about it was that she's been logging the data and learning from that. So, I mean, that's really real world engineering to, come up with a design and then actually follow through to see how is it working? Is it, working the way that it was expected or not? And, tweaking to try and improve the design. I do think that these kinds of projects are really important for kids, and I definitely love to especially encourage them in girls, because I know that a lot of girls drop out of STEM subjects, and especially maths as they move later in their schooling. So I think we definitely have to start at that really early age, getting kids to get excited about STEM and engineering, and also to see the real world applications. So I think it's awesome, this kind of project. I hope to see many more of them in the future.
So next on the docket, let's talk about windbreaks. So interesting article from Science News with some research backing this one, that windbreaks might be a source of increased or like amplified wind power to get some of these turbines producing at a higher output. So, Alan, I know you read through the research that these windbreaks, which are essentially, what is a windbreak, Alan, and how does it, let's start there. What is a windbreak? How does it affect the aerodynamics of the airflow before it approaches a wind turbine?
Well, think of it this way. It kind of shoves the air that's nearest the ground up towards the wind turbine. So you're getting more airflow and some minor velocity increase, I would say, into the turbine to produce more power. And this little research article said up to 10% more power, which is
That's a lot of power. It's a lot of power.
Right.
Yeah.
Because we're scraping away for 1% to 2% and vortex generators and some other aerodynamic fixes. But 10% would be life altering for a lot of existing wind operations. So it makes you wonder, is this realizable in a sense? Can we just go out and build mounds of dirt in front of wind turbines and get that same effect? Maybe it's possible. Our friend Nick Gadern would be able to tell us for sure. But I think if you look in West Texas, a lot of the wind turbines are built at the top of a mesa. So it's like a 200 to 300 foot the land just drops off. I mean, it just literally drops off. So you put wind turbines right at the edge of that mesa. As the wind comes from the valley, comes roaring up the face of the mesa, flips over the edge, and then runs into a wind turbine. You can actually get higher wind speeds by doing that. And so Texas has taken advantage of that. In fact, if you look at a lot where the early wind turbines were sited where there was an elevation change. So it would make sense that some sort of wind fence or wind break type of device or a modification of the soil in front of a wind turbine could, in theory, on a smaller scale, produce more wind. 10% seems like a lot to me, because if there were really 10% out there, I feel like somebody would have tried it already.
Go add concrete barriers beneath each turbine.
Right. I mean, if you're really talking about a 10% increase, it would pay for itself in probably a year. If you were going to need to build some permanent type structure, or at least temporary structure, to deflect the wind.
Plus, it would keep buffalo away. You never know.
Yeah.
You need buffalo barriers, but in my head, I'm picturing a huge concrete, like traffic divider just in front of, onshore wind farms, the base of a turbine, just to push but yeah, so yeah, it'll keep buffalo at bay, maybe bears, probably not kangaroos, Rosie, but
No.
But you're right. But you're 100% right. If this really does work, then that potentially becomes a legitimate thing, right? Where you might build some sort of ramp to.
Oh, sure.
Onshore.
Especially like let's just use the example of Iowa, right? So a lot of the wind turbines in Iowa are built in farm fields, and if you could build some sort of barrier and increase the output of the wind turbine, you will probably do it. So the kicker, I think the kicker is we haven't seen it tried before. We need to really try it somewhere. And obviously in Europe they have organizations that are more research oriented than the United States is, but the United States also has research facilities in which they could try it and see if it does improve the airflow. It's an interesting concept, but we just need to get a little more data to see how real that it is. Because could you think about the offshore opportunities in that also? Do you put some sort of barrier out in the ocean to increase the airflow? Maybe you put an old ship out there and just anchor it and say, okay, wind, hit me. Maybe that's what you do.
Rosemary, what's your take on this? I'm sure you're ready to weigh in, but obviously, I mean, is this something you've heard of before? Has anyone ever pitched you this idea on YouTube or anywhere else as ways to amplify the wind before it gets to a typical wind farm?
Yeah, so do I think that 10% is high? Yes, definitely. But that doesn't mean to say that, a lower percentage couldn't be achieved. And to be honest, 1% would be amazing, a game changer. And even, I've seen people get very, very upset about losing 0.25% of AEP from, stuff that I've done to their wind turbine blades when I, instrument them up to see what's going on. So yeah, you would need a small fraction of that 10% to be real for it to still be a good innovation. But one thing that I did notice with the simulation was they mentioned that they tried a different configuration. I think it was a bit higher or a bit lower, and that was detrimental to the wind farm. So they've kind of found one really precise height that works, and to me that's kind of a red flag that it's just some sort of quirk in the simulation. And I'll be pretty surprised if these results pan out in reality. But like I said, super cheap to try it out. So my recommendation is to go find a wind farm owner that wants to buy a lottery ticket for that 10% AEP gain, and chuck some fences up and see how you go.
All right, and then our last segment today, Alan, we'll toss this to you first. So we've talked about on one of our previous episodes, thermoplastic blades, some of the new research that's come out, potentially showing that they might be viable, and with some new manufacturing techniques to weld them together, which includes putting essentially metal foils between the two halves, joining the two halves, heating up the foils until they melt, weld, and then the foils would remain. So Alan, let's talk first about the lightning implications of this. I'm going to blurt it out. What are the lightning implications of having a potentially well-made thermoplastic blade, but then that still has remaining foils inside of it?
Anywhere you put conductivity in a plastic blade, it will attract lightning. So even if they decided to put heaters, some sort of heater in, say, the leading edge and the trailing edge to bond sections of blades together, if those pieces of metal remain, it is a lower conductive path, the path of least resistance for lightning to follow. Even if it doesn't follow it all the way down, it's going to be one of those places where lightning is more likely to strike. And the problem is that we, wind turbines / aerospace, haven't been really good at predicting where lightning is going to strike or why it's striking there. And there's a lot more we need to understand about aerodynamics and lightning strikes, clearly. And what scares me is I don't think the current regulatory bodies on the aerospace side, or even like the IEC specifications on the wind turbine side, would adequately cover all the conditions in which lightning is striking wind turbine blades. Adding that metallic or resistive element into the blade and leaving it there for the lifetime of the blade seems fraught with hazard. And it wouldn't be my first idea. I would try to find other ways to heat the blade before I would leave something conductive inside of it. Now, there's been some research here in the United States where they've done that thermoplastic melting of the blade and bonding it together. And then over top of what they've done over top of it is they basically put a metal foil over top of the blade surface to prevent the lightning from reaching down to where that heater is. That, I think, will be somewhat effective. But again, do you want to put that on 1,000 turbines and find out the hard way? I think you want to get some turbines in real life situations where lightning strikes much more frequently and check out and make sure that it works before you do make 1,000 or 10,000 turbines using this technology.
Well, and Alan, so if these thermoplastic blades, which are probably, off in the distance, if they start with smaller, say hypothetically they start with smaller wind turbines, the distributed wind market, and we're talking about a 10 or 20 or 30 meter blade, is it still the same concern?
No,
not
what
as
we're
much?
Seeing. Well, not as much, because I think there's been this transition as we've gotten sort of above 50 meters on blade length, and then now we're into the 100 meters on blade length. There are different physics that happen there. You essentially lift yourself so far off the earth that you can the wind turbines are creating lightning strikes. They're actually triggering a bunch of lightning strikes, more so than when they were smaller. So the size does matter in this. And if you're going to do something of an experiment, I think you have to be somewhere in the 60 to 80 meter range, just to make sure you definitely have that the lightning effects and physics are at their maximum effect on these blades. Making something smaller, I think, will give us a false positive. And we see that right now when we have customers call us. Like you don't get a lot of 40 meter blade problems.
So let me jump in there. Why do the smaller scale blades not scale up? Like why are they not accurate when they get out into real world situations?
I think it's a combination of speed, rotational speed, tip speeds, and height. I think those are the two. And the third element here, which we're doing a lot of work on internally, is what the effect of leading edge erosion does on the lightning protection system. So not only would you have to build a big blade and put it in place where lightning is much more frequent, I think you also need to let it sit out there for several years, or to mechanically degrade it and then put it out in service. I do think there's an element of leading edge erosion or damage that happens, and normally to a blade, could be even UV, that degrade the blade's performance and then cause more lightning damage. There's a lot of variables here we do not have a good handle on, and I just don't feel comfortable, because we're not being super successful right now. I would be very uncomfortable about putting big thermoplastic blades out in service without having a little more understanding of what's going to happen.
Well, and here's my last layman question. Why does if the thermoplastic is encasing this metal, why does it not act just like an insulated wire? Like we have wires. I installed a fan in my parents' house, painstakingly, I might add. Like we were like 17 feet up at the pitch of their roof, installing this fan that needed to be replaced for Thank God that my parents, two boys were there. We were up on ladders. But you're up there, all the wiring, and you just put a wire nut, and the insulated wire does the job. It's going to sit there for the next 10 years, and there's not going to be any sparking. It's going to be fine. So why, if we have this huge plastic blade encasing this thin sliver of metal, why doesn't it act the same way and essentially act like an insulated wire where it's fine?
Well, it has to do with how much voltage lightning has with it, which is in the millions and millions of volts, which will break through any sort of plastic barrier. I don't care what it's made out of. You get enough voltage, you'll break through anything. Very few things will handle large voltages. Ceramic, there's certain ceramics that we use on high voltage transmission lines and that kind of thing. But plastics have not been as reliable. And because of the manufacturing variability, as you can well imagine, if you're making a 150 meter blade, it's not going to be perfectly uniform all the way down it, unlike an insulator that's used on a high voltage transmission line, which will be controlled all the way through. It's just a very difficult manufacturing place to make sure things are electrically perfect. It's not the right situation for it. And I think, as we've seen on airplanes time and time again, the best laid plans don't always work out like you think they will. And the laboratory results always throw you off, because you come out with this feeling of confidence, like, I did the IEC test, everything's going to work out great. Or I did the FAA test and everything's going to work out great. And then it goes in service and it doesn't work out great. And you just realize we know a lot about lightning. We don't know everything about it. And wind turbines are growing so fast and the technology is growing so fast that us engineers are having a hard time keeping up with all the lightning related issues that are happening.
So then do you think, even when this comes to commercial scale, whatever scale that is, you think it'll still have to have some sort of external lightning, beside a receptor, but also probably a lightning diverter strip or a foil or like something else, a cap, a tip, a different tip to mitigate these risks? Yeah,
and it'll have to have some other form of lightning protection. The question is what and how much is it going to cost, and can you install it repeatably, reliably on thousands of blades? And we haven't really had a good record of doing that. The existing lightning receptors, I think because we've done it so many times, we've gotten pretty good at it. But other types of lightning protection tossed into a blade do not have that same track record. So there's just a lot to learn. If you just looked at the thermoplastic improvements and wanted to fix the lightning side, you could easily spend 5 years doing that, easily, full-time working on it.
So Rosie, I want to kick this to you and get your take just on the manufacturing. So we talked a little bit about this last week, with just some of the thermoplastic manufacturing challenges. But when you start leaving things inside the blade, like we're using these heating elements to weld the blade together, aside from the lightning stuff, which Alan covered, is that going to pose any problem long term? Like if there's any sort of rust or if there's any ingress of water? What other things does someone need to think about where leaving metal inside of it might come back to haunt you later?
Yes. Okay. So the foil in the wind turbine blade was really interesting to me. I see red flags for manufacturability. A wind turbine blade, it's curved, and it's not just curved in one direction, towards a tip, it's doubly curved. It's not so easy to just take a rigid foil and curve that in two directions. So I think that you're going to, one, see problems with drapability of a metal foil. And two, if you're going to infuse the blade, you're going to have then the impermeable metal foil is going to cause some challenges for the infusion as well, to be able to get the resin both above and below that metal foil layer. And then not to mention the challenge of making sure that you've got a good bond between the foil and the resin. Wind turbine blades are flexing, just constantly flexing over their life, millions of flexes over their lifetime. So you can imagine if it's not really well bonded together, then you might get some separation there eventually. So those would be my biggest challenges from the manufacturing point of view that I would want to look into. And probably they did cover all those points early on in their development. And then the next thing would be repairs, because you definitely don't want any short circuits in between your metal foil and, somewhere that it's not supposed to, the electricity is not supposed to flow. So I'd be worried about when you repair, how you can rebuild that surface so it still behaves the way that it was intended to, and that you don't cause any short circuits in the meantime. Not to mention that when you're doing hot work like grinding, if you've got some metal spark, if you're grinding through metal, then you might get some metal sparks, which could be a fire risk or cause other problems. So yeah, those are the main challenges that I see. And yeah, obviously Alan is well aware about the lightning challenges as well. Yeah, so your specific points about water ingress, well, I'm not sure what exactly the material was. I thought it was aluminium, so I don't think you would need to worry too much about it rusting. I guess you can get surface oxidation, but you would expect that the whole surface is supposed to be covered with resin, so it shouldn't be seeing any oxygen to oxidize. What unforeseen consequences might there be? I don't know. That's why they're unforeseen. Definitely there'll be some, and there's heaps of merit in trying to, test on a small scale as possible, but it's not so easy when we all know that, a lightning test doesn't recreate the exact conditions that you'll see out in the field. And then you can, install a prototype, but you don't know it's going to get struck by lightning, right? I mean, you'd have to install thousands of them to make sure that you got one or two with strikes over the trial period. So, I mean, that's a pretty big trial. You certainly wouldn't want to put out 1,000 blades and then find out your lightning system didn't work and you have to drag them all down and have to redo them. So yeah, I mean, it's definitely going to be very challenging. I'm actually surprised that it's worth it for, they're trying to heat up this joint to bond it together. That's what the metal strip in there is for. It really seems like, the problem they're trying to solve is opening up a much bigger problem potentially. I mean, obviously I'm not involved intimately with the technical challenges that they're facing, but they really open a big can of worms when you mess with the lightning protection system and when you're trying to put something like a metal foil into a blade. So I wish them good luck.
Well, all right. Well, that's going to do it for this week's episode of the Uptime Wind Energy Podcast. Thanks again for listening. Be sure to subscribe to Uptime Tech News. It's in the show notes here on YouTube, Spotify, iTunes, Stitcher, wherever you're listening. So again, if you want to grab our weekly newsletter just with an alert of the new show, some other great news about tech and policy and markets all over wind energy, definitely subscribe to Uptime Tech News. And be sure to follow up with Rosemary Barnes on YouTube. She's an amazing YouTube channel, so you'll find links to her channel in the description as well. From Rosemary, Alan, all of us, we'll see you here next week on the Uptime Wind Energy Podcast. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.